Hello, Algebra Scholars. Section 7.5, Linear Inequalities. We're going back to graphing lines again, but then we're going to do some shading as well. So to graph a linear inequality, we're going to first put the equation into y equals mx plus b form. And our first example down here we can see is already in that form, but no, it's not y equals mx plus b, it's y is greater than mx plus b. We're going to have greater than and less than signs in this section. So we're going to go ahead and graph this line whose y-intercept is, 2. Let's use a red pen. Whose y-intercept is 2 and whose slope is 2/3. So we will go up 2 and to the right 3. And maybe we'll go down 2 and to the left 3. But instead of just simply connecting these dots, we have to be careful to either use a solid line or a dashed line. Because the problem is just greater than and not greater than or equal to, we're going to connect these dots using a dashed line. Okay? And then finally in step 3, we're either going to shade above the line or shade below the line, depending upon which way the inequality is facing. We can see that this is greater than, so if greater than or equal to, we are going to shade above the line, which means that any point that lies above the line is a solution of this inequality. Pretty easy, and you can have some fun using colored pencils. Let's do a couple more on the next page. Okay, algebra scholars, here in this second example, we'll have to do some work on step 1, where the equation is not in y equals mx plus b form. So we're going to subtract 2x from both sides and get 5y equals negative 2x minus 20. Divide by 5, divide by 5, divide by 5. Y equals negative 2/5 x minus 4. So now we're going to graph the line. Y-intercept is negative 4. Slope is down 2 to the right 5. Or up 2 and to the left 5. And let's see, it is, I put an equal sign in. I didn't mean to put an equal sign in. Let's make it a less than or equal to sign. So y is less than or equal to. So because it's less than or equal to, that means it gets a solid line. And because it is less than, we shade underneath the line. So all of the points down here are solutions of this particular inequality. All right, algebra scholars, in these last two little examples here, we'll do something a little bit different. What if the equation were y is greater than 3? Now this is not in y equals mx plus b form. There's no x in it. So we have to remember that whenever we have y equals a number, that implies a horizontal line. So we're going to have a horizontal line at 3, but because it's greater than and not greater than or equal to, it's a dashed horizontal line. And because it is greater than, we are going to shade up. So all of the points above this line are solutions of that inequality. Lastly, if we have x is less than or equal to negative 1, we have to remember that when x equals a number, that implies a vertical line. So we're going to have a vertical line at negative 1, but because it's less than or equal to, it's going to be a solid vertical line at negative 1. Now our rules here don't really apply for shading up and shading down. You can't shade above a vertical line or below, but I think you would agree that left and right will make sense. So less than is left, greater than is right. So less than or equal to negative 1, we will shade to the left of the line. And that's all there is to this section. Easy peasy lemon squeezy.